Well, now that we've derived the reduction formulas for sine and cosine, we can examine the following case, which is the integral of sine to the power of a of x times cosine to the power of b of x dx. And we've already looked at this example, but we did so when either a or b or both of them were odd numbers. But now we will look at the case where both a and b are even. And the general rule of thumb here is we're going to look that first, if a is less than or equal to b, then what we're going to do is we're going to use the substitution here. Sine squared of x is equal to, and it's not even a substitution, it's just a conversion, is equal to 1 minus cosine squared of x. We're going to use this identity to be able to write the integral in terms of cosine only, terms of cosine. So thus, if sine is the more simple function, has the lower power of a, then we're going to write the integral in terms of cosine. And in the case that a is greater than b, well, we're going to do the exact opposite. We're going to say that cosine squared of x is equal to 1 minus sine squared of x. And then we will write everything in terms of sine. Now in the case that they are equal to each other, it's probably best, and that's why I included the less than or equal or the greater than or equal, it's probably best to write these integrals in terms of cosine, because the reduction formula for cosine was actually simpler than the reduction formula for sine. If you see right here, the reduction formula for sine has a negative, whereas in front of the first term, whereas the reduction formula for cosine was positive. So it'll just make things slightly easier for us. But let's look at an example. So our first example, we will have the integral of sine to the fourth of x times cosine squared of x dx. And the first thing that we recognize is that the powers of both of these trigonometric functions are even. 4 is even and 2 is even. So we are going to use a reduction formula. But to do that, we're going to have to write everything in terms of one and one only trigonometric function. Here, our cosine is more simple than our sine, so we're going to write everything in terms of our sine. So we see that cosine squared of x is equal to 1 minus sine squared of x. Now if we rewrite this integral now, we'll have sine to the fourth of x, and this will be times 1 minus sine squared of x dx. Now we can distribute the sine to the fourth of x, and we get the integral of sine to the fourth of x, and this will be minus sine to the sixth of x dx. Now notice that what we've done here is we've rewritten this original integral here on the left-hand side and we've equated it to this integral on the right-hand side, which is the sum of two integrals which are even powers of sine. So now if we use our reduction formula that we derived earlier, here it is at the top, sine to the power of a of x dx is equal to blah 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 blah, then we will be able to solve this integral. So let's do that. Well, we have first the integral of sine to the fourth of x dx, and well, we know that that is equal to, well, here a is equal to 4, so we have minus 1 over 4, and once again I am using this formula here at the top. Well, that is equal to minus 1/4 cosine of x times sine to the 4 minus 1, which is 3 of x, plus, well, this will be a 4 minus 1, which is 3 over 4, times the integral of sine to the a minus 2, which is squared of x dx. Well, now let's just solve for the integral of sine squared of x dx using the reduction formula. Well, now it'll be minus 1/2, it'll be cosine of x, and then times sine to the a minus 1, which will be sine of x, plus, well, that'd be a minus 1 over a, which would be 2 minus 1 over 2, which is 1/2, times the integral of, well, that'd just be sine to the 2 minus 2 dx, which is just 1, so dx. And we get this is equal to 1/2 cosine of x sine of x plus 1/2 x, and then we'll put our plus c in later. So we see here that the integral of sine to the 4th of x dx is equal to minus 1/4 cosine of x sine cubed of x plus, well, this would be 3/4 times, and I'm realizing I forgot my x there, times this result here. So 3/4 times minus 1/2 would be, well, I will put a negative here, minus 3/8 cosine of x sine of x, and this will be plus 3/8 x. Now, so we've solved for part of this, which is the sine to the 4th of x. Now we need to solve for the sine to the 6th of x. But if we think about it, when we solve for sine to the 6th of x using the reduction formula, it's eventually going to be reduced to sine to the 4th of x, which we've already solved for. So once we get to that point, we can just, rather than doing the reduction formula several times, we can just plug in what we already did. So now we have the integral here of sine to the 6th of x dx, and this is equal to, well, let's look at the reduction formula. That would be a minus 1/6 cosine of x times sine to the a minus 1, which would be 5 of x, plus, okay, that'd be a minus 1/a, which would be 5/6 times the integral of sine to the 4th of x dx. But we already solved for the sine to the 4th of x, and that's right here. So what we can do is we can now say that, okay, well, we have the integral of the sine to the 4th of x, and that's going to equal, well, that'd be negative times, or I'm sorry, this is not equal, this is minus the integral of sine to the 6th of x, which is just equal to negative 1/6 cosine of x sine to the 5th of x plus 5/6 times the integral of sine to the 4th of x dx. We will distribute that negative, and we will get sine to the 4th of x plus, well, we'll have a minus 5/6 times the integral of sine to the 4th of x dx plus 1/6 cosine of x sine to the 5th of x. So that when we add these together, we get a minus, or we just get a 1/6 times the integral of sine to the 4th of x dx. This will be plus 1/6 cosine of x sine to the 5th of x. Now we already solved for our cosine to the 4th of x, and it's up here. So now we will just write that in, and we will get a minus, and actually let's write this first term, or the second term first, cosine of x, oh, and the computer is acting a little bit funny right now, cosine of x sine to the 5th of x. Okay, now this will be 1/6 times all of this that we have written up here, so it'll be a minus 1/24 cosine of x sine cubed of x, and then it'll be 3/8 times 1/6. Well, 3/6 is 2, so that'd be 1/8 times 2, which would be 1/16. So it'd be minus 1/16 cosine of x sine of x, and then it would be plus 1/16x plus c. And that right there is the answer to the integral. And that was the integral of sine to the 4th of x times cosine squared of x. As you can see, it requires a lot more steps than does the case that either A or B or both are odd. However, it is pretty straightforward, and as long as you know how to derive one of these reduction formulas, as long as you're careful with your negatives and your constants and whatnot, it should be fairly straightforward. We are going to consider another case, solving for the integral of sine to the power of a of x times cosine to the power of b of x when they're both even, in which we don't use a reduction formula. It's a case that works every once in a while, but generally the reduction formula will be easiest, and we'll cover that in the next one. If you have any questions, leave a comment below, and we'll see you in the next one. Bye.